Hey everyone, welcome back to the channel, and we were discussing problems from our linked list of this sheet, SD sheet. So today we will be discussing implement stack using linked list. The last question we discussed was implementing queue using a linked list. So I'm pretty sure that if you have gone through the last lecture, you now at least you can figure out that how we are going to solve this problem somewhat. Let me just check if yes, I am live. Okay. So let me just explain this problem statement. So you have a linked list and you have to implement the functionalities, the functions push and pop of a stack using this given linked list. Okay. And this is the class we are given, and these are the functions that we have to complete. Now, what you have to do here is that you are given a linked list. Now, using a linked list, how can you implement the functionalities of a stack? Now, what is a stack? You know, stack follows last in first out, LIFO, last in first out. So this problem comes down to, if I have a linked list, okay, for example, if I have a linked list, how can I implement a stack, the functionalities of a stack using linked list? Now you must be wondering what functionalities. Functionalities as in when I say push, okay, push number one. Let's say initially there is no node with me, no linked list node available. The first node that I'm pushing into my stack, first number that I'm pushing into my stack is 1. I have to design the linked list in such a way that my push and pop operations are happening in minimum time, and we can make it happen in O1 of time complexity. In ideal case, not in ideal case, in general case, what if I say push 1, push 2, push 3, and then I ask you to pop, okay, then I say push 4 and I ask you to pop again. What would you do? For example, let's try to implement a general case linked list. What would you do? You'll push 1. One's next should be pointing to 2 because that is the next node I'm trying to push into my linked list. Then I'm pushing 3. So this is the node whose data is 3, and I have linked it with 2. Just general. Now I am asking you to perform the pop operation. So you know this was the first data that I pushed in. If for example it was a stack, then you actually pushed 1, then you pushed 2, and then you pushed 3, and now I am asking you to implement this pop operation. So ideally this 3 should get removed from the top of your stack. What will you do now? You know that 3, whichever node you want to remove from the stack, that will be present in the end of your linked list as a tail node. But do I have the reference to my tail node? No. Either I will have to keep a track of node, or every time when I'm trying to implement this pop, or not implement, every time when I'm making a call to this pop operation, either I keep a new pointer, for example temp, at the head node, and make it traverse through the entire linked list until the last node, right, or second last node, so that I can make 2 dot next as null, so that there is no reference to the last node of your linked list. But in this case, what I'm doing, even if I try to do this, I am taking a pointer, traversing it through entire length of a linked list at that point in time. For example, maximum number of nodes you are inserting is n, and in that case you will ideally be going through the entire linked list. So this will turn out to be, pop operation can turn out to be big of n time complexity. And see, push is simple. You are already simply pushing the nodes. You are keeping the track of your last node, for example, whichever you inserted, like we did in the when we were implementing queue. You're just keeping a track. For example, this is your tail node. Now next pointer that you have added is 3, so your tail points to 3 now. For example, I add 4, so your tail will be pointing to 4, and so on and so forth. So I can easily keep the track of my tail node by, or as and when I'm pushing it, my tail node comes to that node itself. So push still is happening for O1 of time complexity, but pop operation is not coming in, it's taking ON of time complexity. So now think of something better that we can do. A little just a small difference in how we are adding the nodes that will come up here while I'll try to reduce the time complexity of my pop operation. So basically, you know that I do not want to traverse through the entire linked list in order to remove the nodes. What I can do, for example, just have a look here. I am pushing node with data 1. Okay. Now, for example, you have your head node already, and now this is the data that I've pushed. So the node with 1 as its data, I am making my head point to 1. Okay. Next is 2. Now I'm just trying to add nodes in the reverse order. For example, if it was a normal case, I was doing it 1, 2, 3. Instead of this, I am doing 1, then 2 is pointing to 1, then 3 is pointing to 2. This is what I'm trying to do. And how is this going to help me? Have a look here. Next node is 1 whose data is going to be 2. So I will do it in this way, that I'll take a new node by name of temp. Probably temp is your new node with data 2. Okay, whatever data you are adding, a for example. So this temp dot next should be pointing to your head node. Okay, and then head should come back to your temp node. Now what is this? See, for example, the new node is having your data which you are pushing, 2 is a here. Fine. So you made a new pointer by name of temp, right? This is your new node by name of temp whose data is 2. I'm just making a reference pointer pointing to the head node by temp.next is pointing to head, right? And then later on, I am just pointing my head node back to my temp node, so that anybody now new node whichever comes will be pointing to the head node, and that new node will become my future head. Now see, next node that I'm trying to, now let me just take another color. Next node that I'm trying to push is 3. So you take a new node by this temp variable. So now this temp is your new other variable, right? This is your temp variable now whose data is 3. And I want its next by this line temp.next point to head. I've created this link and made my head point to now this node. How is this helping me? You will understand when I implement pop operation. Now I make a call to pop operation. So pop, I can now remove the element which was lastly added into your stack. For example, if it was a stack, how these values were being entered. First you pushed 1, then you pushed 2, right? And then you pushed 3. Now the data that we want to remove should be 3 because that is present at the top of your stack, and I can easily access it with the node having this address by the name of head. So when this was your push operation, I wrote this code for your push operation, right, in which, for example, data A was given. If I talk about your pop operation, I'll write side by side. If I am writing a pop operation, so you are doing nothing, you are simply storing the value of your head node. Head node is pointing to 3. I just am storing the value of this head node, head.data. Now I just want that this node should not be existing as my head. So my head should be transferred to the next node, so that the next value that I have in my linked list should be 2, that is the next of 3, so that I can know that the next, if I have removed this, the top of the stack is 2. So 2 should be the next person to be removed from the stack. So I have to adjust my pointers in that way. So first of all, I'll store the data of this head, and then I'll make my head point to head.next. That's all. And then finally I return x. Right, that is about it. So head's data I have stored in x. Now head is not here, but head is here. Now again, if I'm trying to push 4, so your new temp node is created whose data is 4, and your head from here comes back to here. Now again, I make a call to pop operation. So pop will take the data of this head node, and in your console first you will have 3. Now you will have 4 as your output if I'm printing the popped nodes, right? And your head now again comes back to 2. So in your linked list now you have 2 and 1, and in your stack also you have 2 and 1, because when I pushed 3 I removed it, then I pushed 4 I removed it by pop operation. So that is all about it. Fine, I hope you guys understood this problem. This is your push operation, this is your pop operation. Both of them are taking place in O1, big O of one time complexity. Why? Only an extra space that is being occupied by your linked list is what we are taking of big O of n, that is equivalent to the number of nodes you have. That is all about this problem. Let's code it. I'll just check if you fine. In case you guys have any doubts in this explanation so far, you can write it in the chat, and if not, good, we'll go ahead with writing the code here. So the things that I discussed here, this was your push operation, right? Same things I'm going to implement. So this is your class my stack, right? In which this is how your stack node, in terms of linked list, we used to define node, class node, right, which used to have its data. So that, and the next pointer, this is what they have defined here by name of stack node. So they have already given you, like the one that I'm referring as head, that node has already been defined by them as top. Okay, so wherever I write top, you can map it with the head node that I've used in the explanation. Okay, so let us start off. When I'm pushing, okay, I'm creating a new node whose data is going to be a. So let's create a new node, stack node by name of temp equal to new stack node, and your data is going to be a. Fine. Then what I'm doing is, I already have a top node, right? I want my top node dot next, I want temp dot next pointing to top node, right? Whatever is the top node. What I have done, see, this was, for example, my node, this was my temp node. Already there was some head node, for example, it was null initially. I just made a connection from temp to your head node, basically, right? This was, for example, null also. So, and then I'll make your head point to temp node. Fine. So your top will be pointing to temp now. This is your push operation. Talking about your pop operation, the topmost node will be referenced by your top node, which is analogous to head node. So if you also have to check, for example, I made a call to your pop operation in the beginning. The first operation I'm asking you to do is your pop operation. For example, pop push 1 push 2, for example, this is. So when I'm making the first call as pop, I do not have anything in my linked list, so I should return -1 because there is nothing to remove, right? So you have to put a check. If my top is equal to null, you return -1, and otherwise you take the value of the top dot data, means top nodes data, then you make your top point to top dot next, because now the new head will be your next node, and then you return x. Let's check. Right. So that is all about this problem. In case you have any doubts, you can ask me, else we are done with it. Okay. No, it's not top dot next equal to temp. See, temp is the node which is just newly created with data a, correct? Now I'll explain you this part. If you already understood it, just let me know in the chat, otherwise I'll explain it. Okay, so Shivam Gautam, if you want to understand comparators, then I will tell you the video in which I have taken comparators very in detail, because we were discussing problems based on comparators. So you might have to navigate to previous problem, or you might have to wait for some more lectures. Once I come across that, I will take up the topic of comparators also. Okay, so okay, I was going to discuss this one. Command V, just a second. So this was your push operation. Now have a look here. For example, if I say push 2, push 5, push 1, okay, and then I say pop I say pop. For example, you are doing things like this. So according to my push operation, what I'm doing here is I'm taking a new node, right? In temp. This is my temp node. Have a look. So a new node with the name of temp will be created, which is going to look like this. This is your, sorry. So this is your new node temp, okay, whose data is 2, and you already have a top node which right now has not been given any value, so we can take it as null. So temp dot next is pointing to top, so it is pointing to null value actually, which is actually top, or you can say any node by the name of top. Now what I'm doing it, I always want my top pointer to be pointing to the head of your linked list. So now top is going to point here, and actually this was null, so I'll write null here. You'll understand it when I add 2-3 nodes more. Now have a look at the next push operation. I'm trying to push 5, so instead of pushing 5 after 2, I am going to do it like this, 5 before 2. The reason is, this way I will always get the node that I want to return from the top of the stack right in front as the head node. So this will help me do pop operation in O1 of time complexity. That is why we have used like this. Now temp dot next, okay, now again new node has been created by the name of temp, whose data is 5. So temp, according to this line, temp dot next is pointing to top. This is not temp anymore because I already made top reference to temp previously. So temp dot next is pointing to top, and now your top comes here, points to temp, right? It points to temp, and this is your top node. Now pushing 1. So new node has been created whose data is 1 and by the name of temp, and it's according to this line again, temp dot next is pointing to top. This is your top. Now top, I want it to be always present at the top of my linked list, so this is my new top now, right? This is what we are doing. Any doubts now? You want to start DSA, where I need to begin? If you want to start DSA, start with the basics of any language that you want to implement your DSA in, and then start solving problems from SD sheet if you are trying to target any interviews and all. So that is how it's going to help you by solving as many problems as you can. Target, if you are a very beginner, target small problems, conceptual ones, okay, and then move to the problems that are present in your SD sheet by this GFG. So that is the only way. Try to do questions and always practice by understanding the logic. Don't directly jump to the correct solution by looking at the videos and any stuff from internet. Try to think of on your own, come up with the brute force approach, and even after that you don't understand what will be the optimal one, then you can seek some help and compare why your approach was not a good one or optimal one. So that is how you should always target any question, not directly jumping to the best possible solution, right? You have to first think. Don't spend too much of time also that you're spending around half an hour, 1 hour in trying to crack one. Okay, sometimes you can, but this is how you should do. Fine. Okay, if you guys have any more doubts, just let me know. If not, I will wrap it up. Okay, so you can have a look. This is your code. So if you have no doubts, let's wrap it up, guys. Okay, I'll convey this, Karthik. Sure. We'll take this mostly whenever I try to take, I try to start with one, but sometimes you do not also try to dedicate, means spend more time on brute force approach, because that is something, brute force itself means that is something which should come to your mind the very first time you have a look at the question. This is the reason we directly, most of the times I do discuss, but whenever I feel it's not necessary or it's very easy, I come up with the optimal solution, because that is the intent of taking these lectures, that people who are struggling to get the right or optimal solution can have a help from these videos. Okay guys, thank you. Thanks for watching, and keep coding, keep practicing. See you all tomorrow in the next lecture. Bye bye and take care.